Welcome to the Deep Dive. We're here to cut through the noise and get to what's really shaping our world.
And today, it feels like we're right in the middle of something big.
Yeah, not just a shift, more like an industrial revolution, wouldn't you say? Driven by AI.
Absolutely. And forget just chatbots answering questions.
Right. Imagine AI that actually, thinks, reasons, acts on its own.
It's a massive transformation, and well, NVIDIA seems to be right at the center of it all.
Exactly. So today we're digging deep into their latest numbers.
Yep, we've got the Q2 Fiscal 26 conference call transcript and their recent 10Q filing right here.
Our mission really is to pull out the key bits of info from these sources.
Not just repeating headlines, but finding those crucial insights.
We want to help you grasp just how big this AI infrastructure build-out is becoming.
And the tech behind it, NVIDIA's tech, plus, the opportunities and the challenges that come with it all.
Yeah, get ready for some pretty surprising facts, I think. Maybe a few aha moments.
Yeah, definitely. It might reframe how you're thinking about this whole AI wave.
Okay, so let's start with that big picture. This industrial revolution idea, the scale is just hard to fathom.
It really is. The sources are estimating, what, $3 to $4 trillion in AI infrastructure spending?
Trillion by the end of the decade.
Yeah. I mean, think about that. That's like the entire GDP of a major economy.
Just poured into building AI capability.
Exactly. It shows this isn't just a minor upgrade. It's fundamental, a whole new architecture for, well, everything.
And you can see it reflected in NVIDIA's results, right? Another record quarter.
Oh, yeah. Total revenue hit $46.7 billion.
Which beat expectations again.
Comfortably. And growing sequentially across all their platforms.
It's not just a strong quarter. It's like a massive signal. The demand for this accelerated computing is just booming.
And the engine room for that is clearly the data center segment.
The numbers there are incredible.
$41.1 billion just from the data center.
Wow, that's up 56% year over year.
Yep.
And it's all driven by this insatiable need for training huge models, running recommenders, generative AI, and now this agentic AI stuff too. It really powers everything from the chatbot on a website to complex scientific research.
Exactly. It's the foundation.
Okay, so let's shift from the sheer size of it to the tech. Because Blackwell, the new platform, that seems to be the real benchmark now.
It really is. The GB300, that's the big one, started shipping in Q2.
And the whole Blackwell platform grew 17% sequentially.
That's right. But what's really interesting is who's using it already.
Yeah, tell us about that.
Well, the major players, the ones really pushing the boundaries, think OpenAI, Meta, Mistral.
The big names.
They're already deploying the GB200 NVL72. And not just testing it out.
Right, deploying at scale.
At data center scale.
Yeah.
For training and for inference. So it's already powering real-world AI.
That's fast adoption. Shows how critical they see it.
Absolutely. Immediate validation.
And the performance claims are pretty wild. Like a 10x jump in inference performance.
Yeah, on reasoning models compared to Hopper, the previous generation. CoreWeave is apparently seeing this already with the GB300.
10 times. That's not just faster. That enables totally new things, doesn't it?
Completely. Think real-time AI assistants that truly understand context, or drug discovery simulations that just weren't possible before.
Compressing research time, maybe.
Exactly. Years into weeks, potentially. That's the real revolution hiding behind the chip specs.
Mm-hmm.
And it's not just speed. Efficiency is huge, too.
Right. The power consumption is always a factor.
Massively. The GB300 offers a 10x improvement in token per watt compared to Hopper.
10 times more efficient.
Which in a power-hungry data center world, that's gold. It means lower running costs, potentially more revenue for their customers, basically more compute for the same energy budget.
Makes sense. And for training the models in the first place.
Another big leap. They've got this new number format, NVFP4. It's a 4-bit precision thing.
Okay. What does that mean in practice?
It means they can get 7x faster training compared to the H100. 7 times faster. While keeping accuracy.
Yeah, maintaining 16-bit accuracy levels. It basically changes the economics of training these giant models.
So maybe making it accessible for more players or allowing for even bigger, more complex models?
Both, probably. And crucially, it's not just the hardware doing this.
Ah, the software stack.
Exactly. Things like CUDA, TensorIT LLM, Dynamo. NVIDIA says these software tools have already boosted Blackwell's performance by over 2x since it launched.
So the chip gets faster even after it ships?
Sort of, yeah. Through software optimization, it really shows the power of designing the hardware and software together. that full stack approach.
And that seems to be driving wider adoption, too, beyond just the cloud giants, the RTX Pro servers.
Yeah, they're seeing big uptake in enterprise,
Right.
poised to be a multi-billion-dollar product line, apparently.
And being used for really diverse stuff.
Probably. Hitachi's using them for real-time simulation, Lilly for drug discovery.
Hyundai for factory design. Right, and Disney for immersive storytelling. It's touching pretty much every industry tackling complex problems.
Okay, so the GPUs are the brains.
Yeah.
But you can't build these AI factories without the connections, the nervous system. Let's talk networking.
Absolutely critical. And those numbers were impressive, too. Networking revenue hit $7.3 billion.
Which was a big jump, right? 46% sequentially.
98% year on year. Huge growth. It shows how vital networking is as these AI clusters get bigger and bigger.
So how are they tackling that challenge? What are the key pieces?
They talk about 3 pillars. First is scale up, using NVLink.
Okay.
The latest NVLink basically lets a whole rack of GPUs act like one single massive GPU. It massively increases the memory bandwidth available, which is vital for these complex reasoning models that need a lot of memory close by.
So making the GPUs in a rack work together much more tightly. Got it. What's next?
Then there's scale out. This is about connecting multiple racks or systems together. Here they have 2 main options. InfiniBand is the top choice for the big model builders because it's got super low latency, really important for training performance.
But not everyone uses InfiniBand.
Exactly. So for companies using Ethernet, they have Spectrum X Ethernet. It's a specialized version optimized for AI traffic, high throughput. And that's now apparently an over $10 billion annualized business itself.
Wow. So Ethernet's a big part of it, too. And the third pillar.
That's scale across. This is the newest bit, Spectrum XGS.
What's the goal there?
The idea is to connect separate data centers, maybe even geographically dispersed ones, into these unified gigascale AI superfactories.
They just dash scale.
Yeah. And they project it will double the speed of communication between GPUs across these sites.
Doubling that speed. That must unlock some serious scale. Being able to treat multiple data centers almost like one giant computer.
That seems to be the vision, removing bottlenecks, allowing for even larger, more distributed AI models.
And they're not stopping there, are they? They mentioned the next generation already.
Right, they're sticking to that annual cadence. The next platform is codenamed Rubin.
Rubin. What's in that?
They'll have a new CPU called Vera, the Rubin GPU itself, and other new networking and system chips.
And it's already in progress.
Yep, they said it's in fab, meaning it's actually being manufactured in test runs, and it's on track for volume production next year.
So constant iteration. Compute, networking, systems, software, always pushing forward.
Seems to be the plan. Keep the innovation cycle going.
Okay, let's broaden out from the core tech. AI isn't just staying in the cloud data centers anymore, is it?
Not at all. It's spreading everywhere. Sovereign AI is a huge one.
Right, nations building their own AI infrastructure. Why is that happening now?
Well, it's about national strategy, isn't it? Economic competitiveness, security, maybe even cultural reasons, wanting AI developed within their own borders with their own data.
And NVIDIA sees this as a big market.
Huge. They're expecting over $20 billion in sovereign AI revenue this year.
$20 billion, that's more than double last year.
Yeah. You see examples like the EU planning 20 AI factories with 20 billion O's investment, or the UK's Isambard AI supercomputer 21 exaflops of AI power, all NVIDIA tech. It's a global race.
Fascinating. And even gaming is getting a deeper AI infusion.
Definitely. Gaming revenue hit a record $4.3 billion, driven by the new Blackwell GeForce GPUs.
But it's more than just graphics, right? What's AI doing in gaming now?
Well, GeForce NW, their cloud gaming service, is getting a massive upgrade. RTX 5080 class performance streamed to basically any device.
Bringing high-end gaming to more people.
Exactly. And then there's AI on the device, optimizing AI tasks for RTX GPUs and Windows PCs, things like smart upscaling, AI-powered content creation tools.
And beyond screens. Into the physical world, robotics.
Big strides there, too. They just launched the 3Thor robotics compute platform.
So the Thor.
Yeah. It delivers an order of magnitude like 10x more AI performance and better energy efficiency for robots and autonomous machines.
That's a major jump for robots needing to perceive and react.
It is. And companies like Agility Robotics, Amazon Robotics, Boston Dynamics, they're adopting the full NVIDIA stack.
Right.
That includes Omniverse and Cosmos for creating digital twins, simulating robots before building them.
So giving robots smarter brains, essentially.
Pretty much. Moving beyond just pre-programmed tasks. And then there's automotive.
Self-driving cars. That segment saw big growth, too.
Yeah, up 69% year on year. Mostly from self-driving tech. Their newer chip, the Thor saw.
Another Thor.
Yeah, different Thor. This one succeeds Orin, their previous auto chip. It's shipping now and powers their Drive AV software platform, which is actually in production vehicles.
So autonomous driving moving from R&D into the real world more concretely.
Seems like it. The technology is maturing and getting deployed.
Okay, now for a trickier area. The geopolitical side of things, particularly China.
Right. That's definitely a complex situation for NVIDIA, like for many tech companies. The U.S. government is reviewing licenses for sales of certain chips, like the H20, to China.
How is NVIDIA navigating that?
Well, they mentioned they have received some licenses for sales to China-based customers, but interestingly, haven't actually shipped H20 based on those licenses yet.
Huh. Why not?
They didn't explicitly say why not yet, but they did mention that U.S. government officials have expressed an expectation of receiving 15% of the revenue from these license sales.
15%.
Yeah.
Is that official policy?
They noted no regulation has actually codified that yet. It seems to be more of an expressed expectation at this point.
Okay. But the potential impact is significant if things change.
Absolutely. They suggested it could mean maybe $2 billion to $5 billion in H20 revenue just in Q3 if the geopolitical issues ease up. So it shows how much market potential is tied up in these policies.
It's clearly a tightrope walk.
Yeah.
And they're still pushing for Blackwell to be approved for China.
Yes. Jensen Huang, the CEO, specifically mentioned they continue to advocate for that, stressing the importance for U.S. tech companies to be able to compete in that market.
And the China market is huge for AI, right?
Yeah. Massive. Estimated $50 billion this year overall, and home to maybe half the world's AI researchers.
So just to be clear for everyone listening, our aim here is just to report what NVIDIA said in their call and filings about this.
Exactly. We're conveying their perspective on navigating these trade policies and the potential impact, not taking any political stance ourselves.
NVIDIA's own stated position is that their products are for beneficial commercial use.
Right, and that every licensed sale supports the U.S. economy and tech leadership. That's their argument.
Okay. So, looking ahead then, Jensen Huang talks a lot about reasoning agentic AI. What does he mean by that?
It's kind of the next evolution beyond today's chatbots. Think AI that doesn't just respond to one prompt,
Okay.
but AI that can actually research a topic, make a plan, use different tools or sources of information, and sort of think about a problem for a longer time before giving an answer.
Long thinking. I like that.
Yeah. Now, this apparently needs way more compute power, like 100 to 1,000 times more.
Wow. 1,000 times more.
Because it's doing much more complex processing. But the payoff is it's meant to drastically reduce hallucinations, when AI makes stuff up.
Ah, right. A big problem currently.
Exactly. So this makes the AI much more reliable, unlocks new applications where you really need accuracy and multi-step problem solving. It's about building agents that can actually do complex tasks.
And he connects this directly to physical AI.
Yes. He sees these agentic capabilities leading to breakthroughs in robotics, autonomous systems, the physical world.
He had that quote about needing 2 factories, right?
Yeah, that every industrial company will need one factory to build their physical products and another factory, a digital one, to build the AI for their robots.
That's a powerful image of the future.
It really is. And that vision, that fundamental shift towards reasoning AI, both digital and physical, is what NVIDIA believes will fuel the demand for their whole stack.
The GPUs, the networking, the software, everything working together.
Right. Because to make this happen, especially in data centers that are often limited by power, you need maximum efficiency. That perf per watt performance per watt of energy becomes critical.
Better efficiency means customers can do more, potentially earn more revenue with the power they have.
Precisely. It's a direct economic benefit.
And that's how NVIDIA sees its long-term growth, positioning itself as the infrastructure provider for this whole AI revolution.
Exactly. They call themselves an AI infrastructure company, building platforms like Blackwell and then Rubin after that to enable that massive $3 to $4 trillion global AI factory build-out they foresee by the end of the decade.
They're literally trying to provide the shovels, the picks, the whole toolkit for this new industrial age.
That seems to be the strategy.
Okay, so let's wrap this up. We've really dug into how NVIDIA is, well, undeniably central to this AI-driven industrial revolution.
Yeah, we've seen the record revenues, the impact of platforms like Blackwell, the roadmap with Rubin.
And this expansive vision for AI touching everything from cloud computing to robotics, cars, even national strategies.
And the demand for the underlying accelerated computing, especially for this more advanced reasoning and agentic AI, it's not just growing. It feels like it's hitting an inflection point.
The shift from just chatbots to agents that can actually plan and act.
Hmm.
That feels like a really profound change coming.
It really does. A new era for what AI can do
Hmm.
and how it integrates into, well, everything.
Built one GPU, one network connection, one software update at a time.
Pretty much.
So here's something to think about as we finish. If this move towards reasoning, agentic, physical AI really is a new industrial revolution, what everyday things do you think will be totally transformed in, say, the next 5 years?
Good question.
Like, will your phone's assistant actually start managing your whole life proactively? Will robots be building your next car entirely on their own? What does this mean for how you learn, how you work, how you interact with the world as that line between digital smarts and physical action gets blurrier and blurrier?